Alright, now I'm going to draw a circuit with a battery right there, and coming out of this battery is typical circuit, but this time we've got two resistors in here. Come back over to here. Resistor number 1 is equal to 5 ohms. Resistor number 2 is also equal to 5 ohms. Alright. I'd like to and one more thing, also, as a given, know that I've got 2 amps coming out of this circuit, coming through this circuit out of this battery. Okie dokie. What I'd like to find out is my voltage drops across both of these resistors. My VR2 here and my VR1. I'd like to find out what those are. I'd also like to find out what the voltage total is. So let's find out about the voltage total first. The voltage total will be equal to the current total times the resistance total. Well, what's the resistance total in a series circuit? The sum of all the resistors. I got 5 ohms here, and I got 5 ohms there. 5 ohms and 5 ohms is what? 10 ohms. So resistance total, 10 ohms. Current total is a given. That's 2 amps. And so 2 amps times 10 ohms is 2 times 10. That's 20. Amps times ohms is volts. And there is my voltage total. It's equal to 20 volts. Okie dokie. Let's get rid of this guy. And change voltage total to 20 volts. Okay, so I've got 20 volts for the battery, and now I want to find out what VR1 is equal to. So, using Ohm's law again, VR1 is equal to what? The current that hits this resistor, which is the current total, which is 2 amps. In fact, I don't even have to write that there. 2 amps, because I'm explaining it as we go along. Current total is 2 amps times the specific resistor here, which is 5 ohms. 2 times 5 is 10. Amps times ohms is volts, and we get a voltage drop of 10 volts. What do you know? Let me put that there and get rid of these guys. My voltage drop across R1 is equal to what? 10 ohms. Wow. Alright, what about my voltage drop across R2? What's that equal to? Well, I've got the same 2 amps coming down here, and that hits resistor 2. So what's the voltage drop across resistor 2? It's going to be equal to the same thing as before, the current total times R2 this time. And current total is 2 amps, and the resistance total is resistance for resistor 2 is 5 ohms. I'm going to get the same answer. 2 times 5 is 10. Amps times ohms is volts. I'm going to get a voltage drop of 10 volts across resistor 2. And there we go. Let's get rid of that. Let me make this look a little bit nicer. Like so. Like so. And like so. I'm so happy. Alright, so now I've got voltage, the voltage drop across R2, which is 10 volts. Voltage drop across R1. I've got a current total of 2 amps, and I've got a battery source of 20 volts. There's something very interesting that stands out here. Let's write this down. Let's take at this voltage source over here. Voltage source. Well, energy is coming out of this voltage source. It's leaving it. So I'm going to mark that as negative. That's a negative 20 volts. Because the the energy is leaving the battery. Over here, there's a voltage drop VR1, and this guy is getting hit with all this energy. He's gaining energy, so to speak. There's an expenditure. This guy is in the gain. He's gaining something. So I'm going to put that a positive 10 volts. And this voltage over here, voltage drop VR2, that also is going to be positive because this resistor it's a gain for this resistor. He's getting hit with more voltage, so to speak. He's receiving. The voltage source is losing, negative. And if we add these guys up, negative 20 volts, positive 10 volts, positive 10 volts, we get what? 0 volts. What do you know? So what are we saying here? That the sum of all the voltages around the circuit equals 0. Sum of all the voltages around the circuit is equal to 0. That's interesting. And the guy who thought that up a long time ago was named Kirchoff. And he called it Kirchoff's voltage law, or KVL. Voltage law. The sum of all the voltages around the circuit is always going to give you 0 volts. What do you know? That's amazing. And that's about all I have to say for now. So this is George Boole saying bye-bye.